We have already explained about the function mi in our previous example. This function takes a one-dimensional integer array and number of elements and then returns the largest element index. This function sort takes an integer array and number of elements in it as arguments and then tries to sort the array elements. Here we will be employing the concept of selection sorting. That is, first we will send the array and the total number of elements into the function mi, which returns the index of the largest element out of these n elements. This element value and the last element value will be exchanged. Next time, the mi function is called again. This time we will be sending the array and number of elements as n-1 will be sent. The mi function returns the index of the largest element out of the n-1 elements. Let it be j, that jth element, and the last but one element values will be exchanged. This is repeated for n-1 times, such that the largest element out of the n elements will be going to the last element, and largest element out of n-1 elements will be going to the last but one element. Like that, array gets sorted. This is the concept behind selection sorting. Here we have used the mi function for achieving this. This function will be called from the main. In the main, variables I, n and the array a are declared. A value for n is read from the user. With the help of the for loop, n values are read into the array a. The function sort is called. A and n are sent as arguments to this function. In the following slides, we will try to simulate how the function sort is going to get executed. Remember, we are sending the n value as 5. Once we come out from the function, the last for loop will print the array elements. You can verify that the array elements will be getting sorted. I value is initialized to 0. Is I less than n-1? Yes. Thus, the for loop is going to get executed once. We are calling the function mi and we are sending the array and n-i, that is 5 minus I, 5 we are sending. The function mi returns the index of the largest valid element in the 5 elements, that is 2. Values of jth element and n-1 minus ith element will be exchanged. I value will be incremented by 1. Is I less than n-1? Yes. Thus, the for loop is going to get executed once more. This time mi function is invoked with whole array as an argument and second argument as n minus I, that is 5 minus 1, 4. Thus, this function returns the index of the largest element out of the first 4 elements. That is, it returns 1. That is, 30 is the largest out of the first 4. Its index is 1. It is returning 1, and that will be assigned to the variable j. Now, jth element and n minus 1 minus ith element values will be exchanged. I value will be incremented by 1. I value will be incremented by 1. Is I less than n minus 1? Yes. Thus, for loop is going to get executed once. This time, mi function is called with the whole array as an argument, that is first argument, and n minus I, that is 5 minus 2, 3. What the function returns? It returns 0. That is, j value becomes 0. Now, jth element and n minus 1 minus ith element values gets exchanged. I value will be incremented by 1. Is I less than n minus 1? Yes. Thus, the for loop is going to get executed once more. The function mi is called now. For that, whole array will be sending as a first argument, and n minus 3, 2 elements, 2 will be sending to the function. It returns 1. J value becomes 1. When we apply the exchange operations between jth element and n minus 1 minus ith element, 20 will be there itself. By now, you might have observed that array got sorted. This type of technique is called as selection sorting technique. What we have done? We have calculated the index of the largest value element that we have moved to the end of the array. Again, we have calculated the second largest element index and that we have moved to second element from the end. Like that, we have selected the largest elements and kept in the last, such that array is getting sorted. We have already explained about